and today is a very special day
Mm-hmm.
because it was a three. Tomorrow I will study online,
Mm-hmm.
and either Monday or Tuesday. So I have three consecutive days. I don't have to go to school
Mm-hmm. And why? What
due
is
to the 11th storm because the 10th storm hasn't gone and the 11th storm has already developed.
11? What?
So right now, Vietnam is suffer from 11th storm.
What is that?
So I have to study online because it was flood. You know that I told you about when I walk an hour and 20 minutes to home.
Yes.
Yeah, and that was the effect of the 10th storm. Now it's the 11th storm, and it hits directly in Hanoi,
Mm-hmm.
which means
Okay.
I have to study online tomorrow and even Thursday if the waters hasn't flooded out.
Mm-hmm. Okay, but you mentioned, is it harder than the previous one, or is the same?
It's lighter, it's weaker, but it still cause flood.
Mm-hmm.
And flood is like on your ankle.
Mm-hmm.
So all motorbikes and cars have all recorded dead engine.
Wow.
So traffic jams is everything, and traffic lights are useless
Mm-hmm.
because they don't need to actually control so all. So I have to study online tomorrow due to the 11th. And do you know what more surprising?
What?
The 12th storm is now developed in the cold sea. So I will probably, my predictions, I will study online until next week.
Mm-hmm. So you will not go to school.
Yeah, I will not go to school because
Mm-hmm.
if I go to school by now, it's going to hours. So tomorrow, still study online.
Mm-hmm. Okay, and what is happening? What is happening about? Can you please tell me what is happening about yourself and you? Okay, and your family. Okay, so you are living on the ninth floor. Do you have enough supplies of food, water, and everything else what you need for these upcoming days?
Yes, I've already have enough.
Mm-hmm. Okay, and for how long this flood will be affected on Hanoi?
Probably just 2 days.
Mm-hmm. 2 days. And you mentioned about 12 flood. Well, how are you expected that there will be a 12 flood or some? What is happening?
I would expect it to be. I would say that from myself, I expect it to be like until next week when it's
Mm-hmm.
entirely gone. But the governments have already said that not sooner or later the 12th storm has to come to Vietnam because because this year we haven't have enough storms, so it's of course more. And the 12th storm, not sooner or later, it will eventually go to Vietnam,
Mm-hmm.
and it's kind of developed right now in the cold sea. That
Mm-hmm.
is the sea related that the how that Vietnam owns it and is now developing because of the heat from the air, heat from in the air, and ocean currents that kind of create some hurricanes.
Mm-hmm.
So
And
and it's developing, which means I will like it will go to Hanoi in probably just a couple of days.
mhm. Okay, and well, what is the situation about your grandparents? Okay, is everything okay with them? Because you mentioned before that they are living in the house. What is the situation
Yes.
with them?
House? I don't know
Mhm.
actually.
Okay, okay, and okay. So this is something that is quite often. Is this something that is happening quite often in us late September, beginning of the October in your country? Is this something that happens often?
Um, I think it's not happened very often.
Hmm. Okay, and what are some consequences in your city? Is there anything bad that happened so far in your city?
122 places recorded flood from
Mm.
30 centimeters and above.
So are these places destroyed or?
It entirely covered in flood, and thousands of cars recorded wreck engine. And
Mhm.
all of the mechanics in my city worked countless hours, but the car sense just keeps increasing and increasing.
And what the government can do with these people who used to live in these houses?
I think that kind of like they don't have any because the work is already so large, which means I don't know about this. Probably they will make solutions, but so far I haven't seen anything.
Okay, so yes, okay, so this is okay, so this is something that okay happens, okay, quite often. Okay, I understand what you want to say. Okay, and what do you think? Okay, so this is situation that is happening. Okay, quite often, and now I want to ask you. Okay, so we will start. We have here. Okay. Lesson about Wall Street. Do you know what is the Wall Street in New York?
Nope. Can you set me the word? That word in the TV chat.
Okay, so the Wall Street. Okay,
The worst.
I sent you on Teams.
Okay, so it's an American newspaper to a real street in New York City's financial district, or more broadly, the US financial markets and service industry as a whole, and is a geographical location that houses institutions like the New York Stock Exchange and major banks, and also metonymy of people and activities of the global financial world.
Exactly.
So it's actually a newspaper, it's not a street.
So
But I
this is
don't know anything about this. This is the thing that I read from the first AI overview.
okay. So the Wall Street is about financial things. The most okay about okay. This is the second thing that you read about something that happens with the money. Okay, so when you want to invest money on something, okay, something that can be really expensive, it's like stocks. Okay, so you have here, for example, when people want to invest money in gold, in silver, some valuable things, crops. Okay, so for example, if uh, I will give you one example. In your country, there is a flood. For example, many crops are destroyed. So, for example, the price of the rice or any other crop will be much higher right now because you don't have okay, because of the flood you don't have a lot of crops. But okay, so this is the price of something. Okay, so you have here, for example, uh, some of the things, okay, some of the things cost in 1 year cost for example a lot of money, and in 1 year cost less money. So if people find a lot of gold, okay, so the price of the gold will not be so high. But if they find a gold that it's not so big, and for example a small amount of gold, this gold will be okay, the price of the gold will be higher. So some valuable things, okay, for people who want to sell. And in this place in the Wall Street, you have here a lot of big companies sell their something that or buying some things or selling some things that are quite expensive. Okay, so for example, in your own opinion, what do you think? What is the most expensive things in the world to sell?
Myself,
Oh, okay, but I'm speaking. Okay, yes, yourself, but I'm speaking about materials. Okay, so what? How about some materials? Okay, something like gold, silver, platinum. So what do you think? What is really expensive to buy or sell?
The most expensive thing in the world is even more expensive than Elon Musk. Elon Musk money,
Mm-hmm. Okay. And
and that is antimatter. So
mhm,
I will send you an image. It costs billion, 62 trillion USD per gram.
mhm,
So
mhm,
I will still read you some information about antimatter.
mhm,
And antimatter consists of antiparticles, which are essentially twins of normal matter particles, but with opposite electric charge and other quantum properties like mass and spin. When a particle and its antiparticle collide, they annihilate each other, converting their mass into energy, as described by Einstein's equation: E equal uh, m multiplied by c squared. You know, right?
mhm. Yes.
Okay. And while antimatter is not found in bulk in our universe, tiny amounts are produced in processes like radioactive decay and is used to medical imaging just as PET scans and is being researched for advanced pollution system. And the price of antimatter is 62.5 trillion USD per gram, as I said. And this astronomical price is due to the extreme difficulty of producing and storing it, as it requires massive amount of energy to create even minuscule quantities in high energy particle accelerators, and it requires specialized magnetic traps to prevent it from annihilating upon impact with normal matter. So Elon Musk net worth only have 500 billion. So this is 130 times,
Mhm,
130 times more than Elon Musk net worth. And if a normal person in Vietnam work with the salary of roughly on average is um, $5,000 per year, they would need to work for the time in the for the time equal to the age of the universe. It's 13.7 billion years to get 1 gram of antimatter.
mhm,
And antimatter is also have an idea to let people transport extremely fast, almost the speed of light. Because when they collide, it produce a massive amount of energy, which can actually use as a boost. When I
mhm,
watch a video about is traveling, I will explain to you. There is Imagine a situation like this. Let's imagine we found a planet 10 times bigger than Earth while remaining the force of 10 g per square second, having unlimited food, drinks, and any properties, and it's extreme fresh air that we will have 10 times life expectancy when living in there. And it's only one light year away. So I want to ask, do you think it will be theoretically possible to travel there with our technology nowadays?
mhm,
It's just one light year. So do you think it's possible to travel?
mhm. One light
I want to
year.
ask.
Mm.
Yeah, just one light year. Do you think it's actually possible to travel that distance with our nowadays technology and science?
Nowadays, I don't know because, as you know, it's really hard. It's really hard
Yeah.
to.
So do you think it's possible? Do you
It's
think it's possible?
To be honest, I completely don't know because, as you know, we are traveling.
So just
Uh,
give a guess. Just give a guess of yes or no.
in the future, I think yes. In the future, I
Yes, in
think
the future.
yes.
But in the future, in nowadays, it's theoretically impossible to travel just one. day year, let alone light a year. Now
Hmm.
imagine like this. When I talk about antimatter, but right now I'm reviewing a video as I said, but that's fine. Okay, so do you agree if I just discuss about this video? We talk
Yeah.
about antimatter, but right now we're turning into others.
No, 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 it's
Others.
okay. It's okay. We can change because the topic is really interesting. We can change it a little bit.
Okay, so now let's imagine. The first thing is, do you know about the farthest object that human ever spent to space?
Mm, I don't
Do you
want to
know?
lie. I don't know.
Okay, so it's a Voyager 1 spacecraft
Yes, I heard
that
it.
now traveled 24 billion kilometers, 34 billion kilometers away from from Earth,
Hmm.
and to receive news and image from Voyager 1, it took 22 hours because the distance is 23 hours and 19 minutes of light.
Okay.
So, and do you know how long it took to travel that far? Far, about 24 billion kilometers. Do you know how long it took?
How long?
It's about 40 years to travel. I would round up to one day here. So do you know what if we can what if we can stay on that and travel to that planet? It's going to take 20,000 years. Maybe
Hmm.
just to start. Now there's tons of problems,
Hmm.
billions more problems. First, it's just a spacecraft used to explore nature, and it will eventually disappear.
Hmm.
Nothing is endless. So, if we want to let people travel there, we would need a massive spacecraft. Because there's another reason. It took 20,000 years. So, how can one person, one life expectancy, can travel there? We have to have generations across generations
Of course.
just to travel that. And it's going to take about 200 generations different from each other to travel there. That's the first problem. The second problem is the food and drinks. We are humans, not robots. We need food, we need water, or even course that we need entertaining. If don't, our brain will start reacting straight into us. The third problem is the fuel.
Fuel. Yes, of course.
Yes, fuel. Let's just say the speed of we are so advanced. Do you know that the speed of a normal spacecraft is just 5,000 kilometers per hour? But a but let's just say the technology are so advanced that we create a will create a speed with a new we will create a new spacecraft with the speed equal to what is being started. The starting speed of the spacecraft is 39,000 kilometers per hour. And now, let's just say that we can actually maintain that speed for the entire journey.
Hmm. Okay. So
And
the.
it's going to up, it's going to you know that one light year is equal 9.461 e plus 12. And I don't know what this even mean. It is actually, let me try to read this number, which is 9,400 and 9,460 quadrillion 730 billion 472,000 million 580,800 meters exactly.
Mhm.
So I would take this number and put it in a calculator. So can actually wait, I can't copy it. So let's just say on. Okay, so let's wait for a little bit. And now we have this distance. Exactly. As I said, we're so advanced. We create a spacecraft that maintain the speed of as it just started and divided by 39,000, and the results it's going to took you probably don't like mathematics, but I would say that it took about 242 uh, billion 582 million 832,630
Uh-huh.
30 for example hours to travel there. Now we divide it into three divided into 24 to get days to get a day. We divide by 365, not include leap year, to get year, and we divide by 10 to get decades, divided by 10 to get centuries, divided by 10 to get millennium, and the result is it took 27,000 millennium to travel there. Do you know that the Earth? Do you know that the Earth age of the Earth is only 4.6 billion years? So
Uh,
if we like the age of the Earth is just 4.6 billion years, and now I will divide again to find the years. So we have to travel the distance. It's around 8 times, 8 billion times more the age of Earth.
mhm.
Yeah, 8 billion times more the age of Earth to get there.
Okay, so and
So it's
what do you
definitely
think of
impossible.
what do you think about?
So
Okay, continue. Sorry. Continue.
okay, so the reason I talk about this video is there is one solution that we can actually use this. Is using antimatter. Antimatter can boost when two antimatters, 2 grams of antimatter, each one respectively collide into each other. It will create a massive force pushing the rocket. Yes, a gram of anything, a gram of something, and a gram of antimatter can actually boost rockets. And it's going to took only about 100 years to get there.
Hmm.
But do you know that to store it already extremely hard and costly? So how can we actually create enough antimatter?
How?
Just a single gram alone costs millions of dollars to maintain.
Hmm.
So why would you even want to store 8 kilogram? It's
Hmm.
gonna cost the entire economic the entire world economy worldwide
Hmm. Okay.
to actually store it. So that is the most expensive thing. I would talk about the idea of traveling 1 light year is impossible. As I said, even one a daylight is already impossible since one daylight only divided by 365. So it still took millions of years to travel.
Hmm.
So
And
we're so little. And, I want to tell you about one sad news that is the Earth is going to be destroyed for the next 5 billion years. But that
uh,
we don't care about. Yeah, you know that the NASA are using calculators and actually no, they not predict. They found out the Earth will end. The Earth will end in 1.5 billion years because I probably said to you before, the sun lose 1 billion kilograms of its weight per second on Earth.
mhm,
There are 1 billion kilograms per second in the Earth.
mhm,
And but with that massive force, I will tell you the surprising fact that do you know in our solar system, do you know how heavy is the sun compared to all other planets combined?
How much heavier because it's comparing to, I don't know, comparing to, I don't know the real number, but for example, Jupiter is the biggest planet in our solar system. I know that. But
Yeah.
when you compare, for example, Jupiter to Sun, Jupiter is extremely small comparing to Sun.
So do you know about the sun carries 99.86% of the solar system's weight?
Yes, I know that because
Yeah.
all the planets,
So
all the planets.
in 1.5 billion years, the sun will disappear.
Mhm.
It's now smaller. Actually, it's now like smaller. So in 1.5 billion years, I want to say that the Earth will get totally the magnetic field. The magnetic field will disappear
Mhm.
because the sun's not actually creating it, and so the Earth will spin randomly, and soon will become a dead planet.
Of course, because there is no sun, there is no
Yeah, there's no sun, there's
no
no light like that.
light power. Uh, okay, let's say there is no heat because I assume that people will die if people are still living on planet Earth. They will die because of they will be frozen.
Okay, but talking about do you want to conduct another experiment?
What experiment?
Now imagine what happened if you or me teleport to the sun for one nano, teleport to the surface of the sun for 1 nanosecond,
Oh,
and
I
then
will be
teleport back.
burned.
Yeah, teleport to the sun for the surface of the sun only for 1 nanosecond, and then teleport back to Earth.
Oh, I will be burned.
First, do you know what a nanosecond is mean?
Yes, this is a nano. I think 1 billion. 1 billion part of the second. Is that right?
It's actually 10,000 times smaller than that. And do you know how long can light travel in that nanosecond?
No. To be honest, no.
It's a ruler, a ruler, standard ruler, 20 centimeters. Is the thing is the distance that the that these lights can travel in 1 nanosecond. So now imagine teleport to the surface of the sun for a nanosecond and then came back to it. So I will show you the experiment. Okay, so the first thing, it took 30 million nanoseconds for your brain to even realize what happened.
Okay.
Okay, and the next thing, that when you teleport, in that single moment, the heat from the sun will instantly goes into your eyes,
So I will be
and
blind.
all your body feel heat. But the heat will only be the total heat from your body is spreading out on your body. It's only equivalent to putting your finger into direct matchstick for 1 second and then taking that. Seems extremely hot, but that actually spread out from your body, and you will only notice two things. First, you have on your temperature only increased to about 50 degrees, so you only suffer from a little bit of fever, and
Mhm.
then you notice a sudden flash. I don't laugh here, but you will notice a sudden flash
Mhm.
because you know how light the sun is.
No.
The gamma rays from the sun can instantly vaporize anything.
Mhm.
Your eye is so small. If you just be there for a single second, you will burn out. So, no, so that's experiment. I think it's kind of fun. And the second thing related to that, what happens if you teleport to the core of the sun for 1 nanosecond and came back to it?
No. What happened?
the temperature of the core of the sun is 15 million degrees Celsius.
Okay.
So instantly, when you appear on the sun, you vaporize instantly.
Like I mentioned,
Your
that.
DNA will be destroyed, and you will lose squeeze because the massive force that will squeeze you down, and a process called spaghettified. You will be spread out and pushed and squeezed just like the spaghetti. So it's called spaghettified. And
Mhm.
you will disappear instantly before your brain even
Uh,
know what happened.
realize the time on the
Yes,
sun.
you don't even realize what had happened. If you teleport to the core, and you will be vaporized instantly, even for even for 0.0001% of a nanosecond,
Hmm.
you will still be vaporized. Because there's that extreme heat, you don't know how big 50 million Celsius degrees is. When touch something, it will release an energy extremely massive that can blow up anything.
Hmm.
So that is the kind of like fun experiments that I would to like tell. And do you want to hear more of the experiments?
Yeah, this experiment. Okay, yes, of course, I want to hear about more experiments, but this experiment is extremely good.
No, this is
Uh,
actually not experiments. That's actually
um,
some imaginary
Theory.
situation.
This is like a theory. Theory.
Yeah, if
What can
you
happen?
and the
Yeah.
same thing happened. What happened if you teleport to the core of the Earth for 1 nanosecond and then came back? You will only notice a sudden flash,
Hmm.
and you also how I'm going to say, and you also, but the core of the Earth is 6,300 degrees,
Hmm.
6,300 degrees. So you will feel burn for 2 seconds on each,
Hmm.
which is actually causes damage to your body. And that is a single nanosecond. And that shows us how small we are compared to other things.
Hmm.
And do you want to talk about something else? Probably this class I will just talk.
No, no, it's okay. The topic is really interesting. Okay, and how about other experiments? Okay, so you want to share because these experiments are really interesting. So how about some
Okay.
other experiments that you
So
want
this
to
time
mention?
is actual experiments. Do you know about ink? But not
Yes,
an ink, yes, as a liquid.
of course.
Uh, do you know about tear? Tear. TAR. I will send you an image.
Send me an image. Yes, yes, yes.
Okay, tear. It is a dark, thick, flammable liquid. Do you know? So let me see. This is a tear. I will send you the chat.
Of course. Yes,
Okay, so this is actually considered a solid before, but tear drop experience tear pitch is that a pitch do you watch a video about the world's slowest
yes. Okay.
iPhone?
Send me the video.
Okay,
Okay.
do you know that the pitch is a looks like a solid but behaves like a fluid.
No.
Okay, so I will search for a video that have subtitles. Okay, so I'll share my screen.
Hmm.
Can you see it now?
Yes.
Teardrop experiment. Do you know the video with 36 million views?
Yes, of course. Second video.
Uh,
Even
okay, so now let's watch it.
97 years later, this experiment, still ongoing today, is the slowest experiment in the world. The experiment aims to prove that pitch, which shatters like glass when hit with a hammer, is actually a liquid and not a solid. It was designed in 1927 by an Australian physics professor named Parnell, but it took 3 years for the molten pitch to harden, so the experiment officially began in 1930. The pitch drop experiment, as it's called, took 8 years for the first drop to fall and 9 years for the second, due to the lengthy duration of the experiment. Before the third drop fell, Professor Parnell passed away. To this day, only 9 drops have fallen. Ultimately, it was proven that pitch is a liquid that is 20 billion times more viscous than water and 2 million times more viscous than honey. Currently, the University of Queensland has continued the experiment and they are live streaming it. If you want to see the 10th drop, check the pinned comment. Even
Okay, so as you can see, it's technically a liquid that 20 times more viscous than
Water.
water. So it will eventually, you know that the water has some abilities that is it can flexibly change the shape to be equal to what that actually stored them. So this is technically true. If we give it enough time, it will eventually turn. And pitch is a liquid.
Mhm.
So the experiment was true. And so right now, every chemist book said that pitch is a liquid
Yes.
and it's 20 billion times more tougher than water and 2 million times more tougher than honey. But
And
it's still a liquid. But there's something, it's still a liquid because it's have everything that a liquid has.
okay, but
Yeah, so that is actually a
the
good
the
and fundamental experiment.
the 10 drop. When will happen the 10 drop? What do they call?
For example, 9 years, 9 years, it dropped one. So let me Google. Uh, when did the 10th pitch drop fall? Sometime around 2026 or 2027.
Hmm. Wow.
And they are live streaming it for years. And it's still not stopped. If you're lucky, you can actually find the crazy moments of the 10th one project.
Hmm. Wow. Wow. And do you think is it possible to have the substance or something else that is much, let's say, the texture is much higher than in this ink? So,
I think
for example, some other texture, some other material that is more than ink. Okay, so much higher than ink. So,
ink, yeah, this is pitch. This is not actually turd, it's a pitch. The things when shatters were broken with a hammer is actually a liquid. And
mhm.
this is the only thing besides water having a besides this is the only liquid which is considered a solid and broken with ice.
Wow, wow, this is interesting experiment. Really, really interesting experiment. Okay, and now and okay, so how about some other experiments? Can you show me some other experiment or speak about?
Okay, so let's try to click. Uh, do you know about the legend frost effect?
What?
Legend frost effect.
No, what
I
is
will
that?
send you an email about And I will send you a video about two people sinking their hands into pure metal, which is 850 degrees, and they're hurt. Just they put their hands inside molten metal,
Mm-hmm.
but the hands remain the same.
Can you?
This Malaysian frost effect. So I'm gonna send you. I have two more.
Okay, send please.
Will you read it?
Can you explain? I'm not quite familiar with this.
Okay, so I will share screen again. Okay, can you see it?
Mm-hmm. Just a moment.
Okay, so let's. I will click on this video.
Have you noticed that
Okay, so let's.
Just one moment.
Okay, these are subtitles.
Mm-hmm. Okay.
have you noticed that his hand is touching the obviously hot oil, yet he isn't getting hurt? There's a fast
Yeah, I can see. His bare hand touches hot oil, 100 degrees, and didn't burn.
Mm-hmm.
Okay, so this will explain.
fascinating physics phenomenon at work here called the Leidenfrost effect.
Yeah, that's London first.
When the skin comes into contact with the hot oil, some of the natural moisture, like sweat, on the skin instantly vaporizes because it has a much lower boiling point than the oil. This
Okay, so as you can see, sweat from the hands vaporize instantly because the oil is significantly harder, right?
Yes.
Yeah,
creates a thin layer of steam
yeah.
that
So it's creates like again as for a phrase, the super thin layer of thin that actually protect you from a split second before it actually touches skin.
shields the skin from direct contact with the hot substance for a brief moment.
Oof.
Have you noticed
Just for a brief moment only. So that is a fun experiment, but of course the truth is no.
Mm-hmm. Yes. Don't try this at home.
Yeah. So this is actually fun. And some people, you know that this is actually extremely popular. And people have used it. Do you know about the non, like, have you ever, for example, cook an egg, fried egg, but it ended up stucking on the top of the plate? Wait, of the top of the, wait. What is this said in English? I instantly forgot.
Let me check. Okay.
Now, what is this said?
This word. Pan. This is a pan.
Pat.
Pan.
Yes.
Pan.
Yeah. Yes. Okay. So, have you ever fried an egg and would ended up stucking on the pan?
No. To be honest, no.
No, you fried an egg.
Okay.
Have you ever fried an egg before, or you just eat it boiled, hot boiled?
Okay. I fried the egg. Of course, I fried the egg.
You fried and you ended up stucking on top of these.
Yes.
Yes. So, the Vietnamese use something called a non-stick, non-stick, like a non-stick pan by using the Leidenfrost effect. And this is that pan is created by when the water boils inside the pan, instantly adding cold waters and put it in hot water again. This will create a change in pressures, and we using the Leidenfrost effect to actually creating a thin layer and that's stuck on the side of the pan and stop it from getting stuck.
Uh-huh.
So, do you want to have another?
Of course, of course. Why
Yeah.
not?
Okay, so wait for me a little bit. Okay, so I'm sharing the screen again. Can you see it now?
Yes.
Okay. I tested super cooled water.
Mm-hmm.
Okay. The process called super cooling. Okay, now let's start the video.
Is super cooled water, and it's really easy to make. First, leave purified water in the fridge for 3 hours, then move it to the freezer for another 2 hours. This puts our water into
Okay, so as you can see, I will explain a little bit. Put in the fridge for 3 hours and then the freezer for 2 hours. But you notice that the water doesn't actually change at all.
Mm-hmm. Yes.
Yes, and there's two reasons behind this. First, do you know how ice is made?
Uh,
How ice,
how ice is made. Okay, you put
like
water.
how can we put water into how can we put our water into the fridge and it freezes into ice? So
Uh,
what the mechanism of fridge is, do you know?
okay, below zero. Is that right?
Yeah, and it's actually not that because of something called crystallization. That's the process of uh, that or pure water don't contain it still contain just anything. And when we put the water to the fridge, the molecules inside the water start to form a hexagon like things, and it starts to crystallize. So that is why it's called crystallization. And second, the Fiji water you saw in this is completely purified. It's of nothing, water 100%. So it can't be free since there's no starting point for the water to start the crystallization process.
Mm-hmm.
So let's see if my things are clear.
a super cooled state and remains a liquid but can instantly turn into ice. This happens
Yeah, you can instantly turn into ice when you smash it.
Mm-hmm. Of course.
This is fun. Okay.
because purified water doesn't have the chemicals or dust to start the crystallization process.
Here, as you can see, I threw. There's no starting point.
And only when it's disturbed will the water turn into ice. Pouring the water on itself also triggers the crystallization process. Click here to see more experiments.
Okay, so as you can see, you can also try this in your own fridge and surprise to your wife, for example, or the son,
Mm-hmm.
the crystallization process.
Okay. Yes. Of course. I can try that. This is something that can be
And
interesting.
Unfortunately, I don't have any more experiments.
No, no, it's okay. But this experiment is it's really nice. Do you know, for example, that also if you put alcohol in a freeze, that alcohol will not be freezed. Do you know that?
Yes, because it have a lot of different things like grapes or any chemicals, and so because of the about the population rate. So because there's a lot of different chemicals, there's no water. The alcohol is no, it's mostly C2H5OH. So there's little water that the crystallization can't start.
Mm-hmm. Okay. Yes, I'm quite familiar with this. Okay. Okay. I know that. Okay. And crystallization. Okay. And what do you think? What do you think about some other materials that cannot be frozen? Okay. What other materials? Do you know any other materials?
That is like a liquid, but not liquid, like alcohol, sulfuric,
Mm,
or any kind of acid. It be a liquid, not water. So it can't be stopped to crystallization.
mhm. Okay. So this is this is something that cannot be sorted by crystallization. Okay, and yes, okay, so we spoke about high temperature and low temperature. And on this experiment that you mentioned, okay, when in 1.5 billion years, next, okay, so what do you think, in your own opinion, what do you think will happen with the Earth? Okay, so what is something that happen is going to be burnt or is going to be cold? Okay, so
It's going to be eaten by your sun because it grows larger. I forgot to say.
what is
It grows larger.
Earth? Earth?
But the weights get lighter. By the time of this, before we start the class, the Earth, I don't know what to say, but it's already lose a bunch of its weight.
Mm-hmm. Yes. Okay. So what people could do in this situation?
What?
What is something that people can do in this situation? Imagine, for example, in 1.5 billion years. So what is something that people can do?
What you can do? I don't have any idea.
Maybe to find maybe to improve technology to find some other planet that look like Earth in a solar system, in any other solar system. Okay, so for example, as you know, the sun is the star. Okay, so maybe
Yes.
to find some other planets that look like Earth and move to this place. This is one solution that come up on my mind because, as you know, the sun is relatively small star. It's not so big. You know that. That's
Yes.
the sun, for example, when you look at the texture of the sun and everything else in other stars, in other solar system, the sun is very, very small comparing to other stars. There are bigger stars than sun. Okay, Kang, interesting lesson today, very interesting lesson. Okay, so now I have to go because I have another class, but see you on Saturday, okay?
Yes. Yes.
I wish you a good night.
Yeah.
Bye bye.
Bye.
Bye bye.
Yeah.